Question number 14. Given that x cubed minus x squared minus 17x minus 15 is equal to x plus 3 into x squared plus bx plus c, where b and c are constants, find the value of b and c. Now we require to find the value of the variables b and c here. So for this, we are given, left hand side we are given an expression x cubed minus x squared minus 17x minus 15. On the right side, we will expand the brackets and we will equate the like terms. So we have left side, we still have the same thing. Right side, if we multiply, we have x cubed plus bx squared plus cx plus 3x squared plus 3bx and lastly plus 3c. Now we can see what are our terms for, we have x cubed here and we have x cubed here, which is the same. We have now x squared term here and we have x squared term with bx squared and 3x squared here. And lastly, we have the x term minus 17x with the x term here cx and 3bx. So let's equate the terms on left hand side and right hand side. We know that x cube is equal to x cube, so that is very clear. For the x squared term, we equate minus x squared to the 2x squared terms on the right side, which is bx squared plus 3x squared. Now we can remove x squared common from the right side. So we have b plus 3. We can cancel out x squared. So what we are left with here is negative 1, because negative x squared is negative 1 into x squared. Negative 1 is equal to b plus 3. Therefore, b is equal to minus 1 minus 3. 3 goes to the other side and becomes negative. So we have b is equal to negative 4, and we got the value of b. Similarly, we will equate the term containing x. So we have negative 17x on the left side. That is equal to cx on the right side plus 3bx on the right side. So we have minus 17x is equal to, remove x common out, c plus 3b, cancel out the x and the x. So we have minus 17 is equal to c plus 3b. Now we already found the value of b to be negative 4. So we can substitute this value. We have minus 17 is equal to c plus 3 times negative 4. Since we already found b to be negative 4. So minus 17 is equal to c minus 12. So minus 17 plus 12 is equal to c. Therefore, c is equal to negative 5. And we have our values for b and c. So that is for part A. The second part B says, hence fully factorize x cubed minus x squared minus 17x minus 15. So let's write the expression x cubed minus x squared minus 17x minus 15. We need to factorize this. When we think of factorization, the first thing that should come to our mind is whether or not there is a common factor in the terms. But we see that we do not have anything common here. So since it is a cubic expression, we cannot even do product and sum or any other method. So what we require to do here is we will find out what is a factor, what is a likely factor in this expression. So we will start by plugging in values. we can start by plugging in x is equal to 1 or x is equal to -1, and we will see what is a factor. This is known as the division method. Factor theorem. So when I plug in x is equal to 1, so I get 1 cube minus 1 squared minus 17 into 1 minus 15. So that is 1 minus 1 minus 17 minus 15. So in order for x is equal to 1, if x is equal to 1 gives me 0, then x minus 1 is a factor. But this does not give me 0, so x minus 1 is not a factor. X minus 1 is not a factor. Let's try with x minus 1. So for x cubed, I will substitute minus 1. So minus 1 cubed minus minus 1 squared minus 17 into minus 1 minus 15. So I have here minus 1 minus of positive 1, so that is minus 1 plus 17 and then minus 15. So I have basically minus 2 plus 17 minus 15, which is 15 minus 15, which is indeed equal to 0. So I have plugged in minus 1 here. Therefore, x plus 1 is a factor. So when x plus 1 is a factor, why do we plug in -1? Because when we equate the factor to 0, we get x is equal to -1. So when we get our 0 by plugging in -1, that means that x plus 1 is a factor. So we got one of our factors. Now we can find our other factors by using long division, algebraic long division. We have x cubed minus x squared minus 17x minus 15, and this needs to be divided by x plus 1. So we divided with our factor, which is x plus 1. So what should we multiply with x in order to get x cubed? We need to multiply it with x squared. So we will multiply it with x squared. We get x cubed. Now x squared will also be multiplied by positive 1. So we get positive x squared. We subtract. So this becomes minus, this becomes minus. X cubed take away x cubed 0. Then minus x squared take away minus x squared gives us minus 2x squared. We bring down the minus 17x. Now what should we multiply with x in order to get minus 2x squared? So we need to multiply it by minus 2x. So we multiply this by minus 2x. We get minus 2x squared. Now we need to also multiply the minus 2x with the positive 1. So we get minus 2x. We subtract, so this becomes positive. This becomes positive. Minus 2x and 2x cancel each other. 17 minus 17 plus 2 gives us minus 15x. We take down the minus 15. Now what should we multiply with x in order to get minus 15x, which is minus 15. So we multiply minus 15 here. So x into negative 15 gives us negative 15x, and also negative 15 into 1 gives us negative 15. We subtract, this becomes positive, positive. They cancel out and they cancel out, and our remainder is 0. So we get our other factor as x squared minus 2x minus 15. So our other factor is x squared minus 2x minus 15. So we have our first factor, x plus 1, which we already found earlier. Our second factor is x squared minus 2x minus 15. Now, since the question says factorize fully, as we can see here, it says fully factorize, we need to also factorize the quadratic expression here because it can be further factorized. So we can do this by using the product and sum method. Product is negative 15, sum is negative 2. So we have 3 times 5 minus 5 plus 3. So we have x plus 1 into x plus 3 into x minus 5. And these are our factors for x cubed minus x squared minus 17x minus 15. And that answers question number 14. Moving on to question number 15. Given that y is equal to 1 divided by 64 x cubed, express each of the following in the form of k, some constant k, multiplied by x to the power of n. Alright, so the first thing we have here is we are given y to the power of 1/3. So all we will do is we will replace this y with the value of y which is given to us here. So we will write this is equal to 1 upon 64 x cubed to the power of 1/3. This is the same as x cubed divided by 64 to the power of 1/3. Now power of 1/3 outside the bracket means the power belongs to the numerator as well as the denominator. So power of 1/3 means take cube root, which means we need to cube root. So x cube when cube rooted gives us just x, or we can simply cancel out the 3 and the 3 here, so we are left with x to the power of 1. And in the denominator we have cube root of 64, and that is 4. So our answer is x divided by 4. Now since we need to write it in the form of k x to the power of n, we write the k as 1 by 4 and x and the power of n is 1. So that's our answer for A. Let's move on to B. We have 4y to the power of negative 1. Once again, we have our y value here. We will just substitute it in place of the y we are given here. So we have 4 into our y, which is 1 upon 64 x cubed to the power of negative 1. Now when power is negative, we can swap the fraction and the power becomes positive. So once again, when the power is negative, so the power is negative here, we can swap the fraction. We have a fraction here which is basically x cubed divided by 64, or we can take the reciprocal, in other words, and that will give us 64 divided by x cubed and the power will become positive. So we have 4 as it is. We take the reciprocal, or we swap the numerator with the denominator and the power becomes positive. Now we have 4 times 64. So 4 times 64 is 256 divided by x cubed. Since x has to be in the numerator in this form, we will bring out the x in the numerator. So this is 256, and when x comes in the numerator, the power becomes negative. And that is the answer for question 15b. Moving on to question number 16. Question 16 says, show that 5 divided by 75 root 75 minus root 50 can be written in the form of root a plus root b, where a and b are integers. So let's write the question. We have 5 divided by root of 75 minus root of 50. So first let's see if we can simplify the roots. 75 is 25 times 3. So I can remove out the square from inside, and 50 is also 25 times 2. 25 being square number comes out, so I have 5 divided by 5. So 25 comes out to give me 5. 5 root 3, again 5 root 2. So now 5 root 3 minus 5 root 2, it cannot be simplified. So now we need to work it out. Now the denominator is separated by a minus sign. So we will multiply it, the fraction, with the same denominator separated by the plus sign. So we have 5 divided by 5 root 3 minus 5 root 2 times 5 root 3 plus 5 root 2 divided by 5 root 3 plus 5 root 2. In the numerator, when we multiply 5 with the bracket, 5 5s are 25, 25 root 3, and 5 5s are 25 again, 25 root 2. In the denominator, by a minus b into a plus b, we have a squared minus b squared. So the numerator remains 25 root 3 plus 25 root 2. We cannot simplify that. And the denominator becomes 5 squared, which is 25. Root 3 squared is 3. Minus, again 5 squared is 25. Root 2 squared is 2. So we have 25 root 3 plus 25 root 2 divided by 25 3s are 75, 25 2s are 50. So we have 25 root 3 plus 25 root 2 divided by 25. We can remove 25 common out from the numerator. So we have 25 root 3 plus root 2. So we are factorizing the numerator, divided by 25. Cancel out the 25 and you are left with root 3 plus root 2, which is the required format of the answer.